Osmosis. The diffusion of water across a semi-permeable membrane where the solute moves from a high water concentration to a low water concentration. Several experiments were conducted in the laboratory to highlight osmosis, such as first, the U-tube dialysate experiment, where tube A is having left hypertonic side, right hypotonic side, which eventually tube B, after homeostasis, resulted to an elevated water level at tube B left side. That is by reason of osmosis. Second, the potato experiment, where potato A increased in volume and size after being immersed in hypotonic solution. Potato B shrunk in hypertonic solution. And the third, the egg experiment, where egg A shrunk in hypertonic solution and egg B swell in hypotonic solution. All the said experiments were concluded, and that it proved that the movement of water molecule started from high to low concentration via osmosis. The types of solution. Solutions are classified according to the concentration of the solute, and that will lead us to the word tonicity. The types of solution can easily be understood by playing along with the word prefix and suffix. Isotonic is a combined word. Iso meaning equal, hypo meaning low, and hyper meaning high. All of these are referring to the concentration of the solute. Once again, iso is equal, hypo is low, and hyper is high. To fully understand the effect of a solution to the cell, let us look into the body fluid compartments. There are two general distinctions. At your left is the intracellular fluid, or what we call the ICF, which represents 2/3 of the total body weight. At the right side is the ECF, or the extracellular fluid, which represents 1/3 of the total body weight. Together, this compartment is separated by a cell membrane, which we considered as semi-permeable. The extracellular fluid compartment is further divided into interstitial fluid and the intravascular fluid, which are further separated by the capillary membrane. Now, in order for you to understand the effect of the solution to the cell, you have to be reminded that the solution, before it affects the cell, usually stays in the ECF. And from there, your isotonic, your hypotonic, and hypertonic will cause on an effect. Let us analyze the effect of osmosis in relation to varying solution. There are three identified tonicity: the hypertonic, the isotonic, and the hypotonic. In hypertonic at your left, you will administer a highly concentrated fluid to the ECF. Water in ICF will come out. As if it is magnetized, water movement is from ICF to ECF. The cell will shrink and shrivel. And in worst case scenario, plasmolysis will result, and osmosis-induced cell death. In isotonic solution, ICF is equal to ECF. Therefore, everything is normal. No water will come in, and no water will come out. However, in hypotonic at your right side, a low concentrated fluid will be administered. ICF will have a greater concentration than ECF. More water will be invited inside the cell. Therefore, the cell will swell. And in worst case scenario, cytolysis or osmotic lysis or desplasmolysis will cause the cell to swell, burst, to cell destruction. Hypertonic, a solution with a higher concentration of solute. The cell is expected to shrink. The following are the IV fluids available under hypertonic. And indication is during electrolyte imbalance. Contraindication, it should not be given in cases of fluid overload and edema. Isotonic solution, meaning there is an equal concentration of a solute, and this will result to a normal cell. These are the available IV fluids under isotonic solution, and these are the reasons why there is a need to administer isotonic solution in cases of blood loss during surgery, in dehydration situation, and blood transfusion. Hypotonic, a solution with a lower concentration of solute. It will result to cell swelling. The following are the IV fluids available under hypotonic. The indication will include vomiting, and contraindication will include increase in intracranial pressure during burns condition and during trauma. Active transport. It requires an energy or ATP to move materials from low to high concentration. This is against the concentration gradient. There are two types of active transport, either an endocytosis or an exocytosis. The two processes may either import or export macromolecules. It can either be in the form of hormones, metabolites, proteins, foreign bodies, and even the invading microorganism. Endocytosis is the importation of a macromolecules that is from the outside cell going inside. And this is accomplished by the formation of a new vesicles. However, exocytosis is the exportation of a macromolecule either from the inside going to the outside, and this is accomplished by the fusion of a new vesicles. The three forms of endocytosis. Phagocytosis. This is also known as the cell eating. It is being accomplished by using a pseudopodia or the pulse pit, which surrounds and envelopes the invading microorganism. It engulfs the whole particle, and by the use of enzyme, the lysozyme and cathepsin, it finally dissolves and destroys the particle. The pinocytosis. It is also known as the cell drinking, the taking in of a liquid droplet, or either smaller bits or fragmented particles. And finally, the cell-mediated endocytosis. It is the process where the cell absorbs particle by inward budding or by invagination. Once again, we have reached the end of the topic. You may pause the video. Let's assess and check your comprehension. That's all, folks. This has been your Nurse Radiologico Guro saying thank you for watching and enjoy studying.